Hello everyone, hope you're all going good. So in this session I'm gonna explain about the binary trees. So first of all we see what is a tree. So unlike arrays, linked lists, tags, queues, these all data types are the linear type of data structures, but tree is a hierarchical type of data structure. So first of all, we see that this diagram. This is a tree of J is a root node, and as a root node it must placed at the top of the tree, and J has two children, F and K. So these are the children of J, and J is the parent of Fk. So Fk has children's. F has A, H as a child, K has a child of Z. So A, H, Z are children of F and K, and A, H, Z have no leaf elements, so no childs. So these are called leaf elements because of no childs, and F is a parent of A, H. So this is the structure of a tree. So where we use these trees? So one reason to use trees might be because when we want to store information that naturally forms a hierarchical. So for example, a file system on our computer. So our file system on our computer will be placed in hierarchical format. So this is the tree structure of a file system. So a root element and a home page and somewhat of documents, and in a home page some of the hierarchical documents present over here, and finally we have a files over here. So trees provide moderate access search, and it was quicker than the linked list and slower than arrays. So trees provide moderate insertion and deletion like linked list, and unlike arrays, trees don't have an upper limit on number of nodes, as nodes are linked using pointers. So we can insert n number of elements into a tree. So that's it. And the main applications of a tree include manipulate hierarchical data and manipulating sorted list of a data, and use it for routing algorithms, and that's all. So when we have in the tree we have a called a binary tree. In a binary tree whose elements have at most two children is called a binary tree. Since each element in a binary tree can have only two children, we typically name them left and right childrens. So as it is average only having only two children, we call them as a left one and the right children. So let's see some more. So in Python programming we see how this data structure can be implemented. So it's a Python class that represents an individual node, so in a binary tree. So we took a class as a node, and def, init, self, and key is a parameter. So self.left is equal to none, and self.right is equal to none. So self.value is equal to key. So it's a left node and the right node, and the value of a node of containing the left and the right children. So it's a complete binary. It's not a complete binary tree, but it's a sample node of a binary tree. So let's see. And so now let's see the simple code of a simple binary tree. So Python program to introduce a binary tree, a class that represents an individual node. So we already saw this code. So now we create a root node. So root node is equal to node of 1. So in every binary tree, the root node is only 1. So we create one root node. So the root node look like this. So it's a root node, and the root node will contain children's. So root.left is equal to node 2, and root.right is equal to node 3. So we are giving a label as 2 for the left and 3 for the right, and 2 and 3 becomes left and right children of 1. So now 1 is a parent and 2, 3 are the children of 1. So now, so in how our output comes, 1 is a root node and 2 3 are the childrens, and we also given 2 3 can also contain childrens and cannot be a children. So here 2 has no child at present. So now let's see, root dot left is equal to node 4. So root is this and root left is 2, and dot left means 2 left is none here. So we are replacing this none by 4. It means how it, the where it plays means root 1 here and 2 and 3, left dot left means left of left, so it's 4, and remaining all none. You can also insert elements by your convenience. So after creating an element, it also had none because it may also have a children. So when we print our output, we see that 4 becomes the left child of 2, and remaining all none, and that's it. So this was the output, and our collab compiler cannot represent in a graphical way, but we can use other compilers to get a GUI interface. So that's it. Thank you for this video.